So Apple had its WWDC event this week, and most of the coverage is about Siri getting a chatbot app or iOS 27 or whether Apple is catching up in AI. That is all fine, but I think everyone is missing the most important thing that Apple announced, and it has nothing to do with Siri. Apple shipped a 20 billion parameter AI model that runs on a phone, not in the cloud, on the phone. And if you're building anything that needs AI outside a data center, robots, edge devices, system in remote environments, this is the most important signal the industry has sent in years. Let me explain why I care so much about this. I'll be honest with you. I care deeply about local AI models, not as some abstract technical preference, but because they are fundamental to making robots work in the real world. Here's the thing. A robot cannot wait for a cloud response. When a robot is navigating rough terrain, manipulating objects, or operating around people where safety is critical, the round trip to a server introduces latency that is just unacceptable. And in many of the environments where robots are most needed, I'm talking about deserts, planetary surfaces, underwater, remote industrial sites, there is no network at all. Not intermittent, not slow, zero connectivity. The cloud is not an option, period. So every advancement in local model capability matters directly to robotics. When a model gets smaller without losing capability, when quantization improves, when new architectures make it possible to run bigger models on constrained hardware, each of these is a direct unlock for what robots can do in the field. I'm experiencing this firsthand. I'm currently using a local model setup for a project where I cannot send code to a third-party cloud provider, compliance reasons. And the local model is not just functional, it's actually very useful. 6 months ago, that wouldn't have been even possible for this kind of work. The capability has crossed a threshold. That's what makes Apple shipping a 20 billion parameter model on a phone so significant. It's not just Apple's ecosystem that benefits, it's a validation that local inference is ready for serious work. The tooling will improve, the models will get better, the gap between cloud only and local first will keep narrowing. Now, what is good enough local inference look for a robot in the field? Honestly, it's hard to define precisely. It's one of those things you will notice when you see it. But the direction is clear. The more the model can do locally, the more useful the robot becomes, especially where the cloud is unavailable, unreliable, or not allowed. For context, I've been running Qwen 3.7 and the recently released Gemma 4 models on a Mac Studio with 64 gigs of memory. The capability is real. These models are useful for serious work, not just demos. I'm also closely following the NVIDIA Jetson Spark and the AMD solutions. The hardware landscape for local inference is moving fast, and the models are keeping pace. What Apple actually announced? Okay, so let me break down what Apple actually announced. Because it's not just one model, it's a family of 5 models. Apple shipped what they are calling AFM3, Apple Foundation Models 3rd generation. 5 models split across 2 locations, on your device and in the cloud. On the device, there are 2 models. First, AFM3 Core. That's a 3 billion parameter model. It runs on Apple Intelligence devices. This is the everyday model, quick replies, basic search, simple app actions. Second, this is the big one, AFM3 Core Advanced. This is a 20 billion parameter model. But here's the trick, it only activates 1 to 4 billion parameters at a time depending on the request. The full model sits in a flash storage. When you send a prompt, a lightweight router picks the right experts and load only those into active memory. Apple calls this instruction following pruning. It's how a 20 billion parameter model runs on a phone without needing 20 gigs of RAM. This model is multimodal. Text, images, audio. It powers the more capable Siri features like expressive voices, high accuracy dictation, visual understanding, but it requires top-tier silicon. We are talking A19 Pro M4 chips, which are at least 12 gigs of RAM. Then in the cloud, there are 3 models running on what Apple calls private cloud compute. AFM3 Cloud is the server workhorse tuned for speed. It runs on Apple's own silicon. ADM3 Cloud handles image generation, Image Playground, Gmoji, and also on Apple Silicon. And AFM3 Cloud Pro is the most capable model for complex reasoning and agentic tool use. This one runs on NVIDIA GPU in Google Cloud inside Apple's private cloud compute enclave. Your data gets processed and wiped. Operators can't access it, and outside researchers can actually verify those claims. So, how does routing work? When you ask Siri something, a system orchestrator decides, can the 3 billion model handle this? If not, does a 20 billion model need to kick in? If it's still too complex, it goes to the cloud, but only the structured prompt goes, not your raw data. Lightest work stays on the device, heaviest work goes to the most powerful hardware. And for developers, the foundation model framework gives you the on-device model through a Swift API. 3 lines of code to prompt the on-device model, 1 line change to switch to the cloud. Same structured output and tool calling either way. No API keys, no token cost for apps under 2 million downloads. Go deeper to the 20 billion on-device model because this is the part that should make anyone building edge AI pay attention. Running a 20 billion parameter model on a phone is not trivial. Most large language models need all their weights loaded into fast memory, DRAM, at once. A 20 billion parameter model at standard precision would need roughly 40 gigs of RAM. That's far more than any phone has. Apple solved this with 2 techniques. First, sparse activation. The model is organized as many experts. For any given prompt, only a subset is needed. A lightweight router picks the right ones. In this model, only 1 of 4 billion parameters are active at any given time. Second, instruction following pruning. The full 20 billion weight lives in flash storage. When a prompt comes in, the needed experts are loaded into the DRAM, processed, and the rest stays dormant. Apple designed this so the bandwidth bottleneck between flash and DRAM doesn't kill performance. The routing decision is made per prompt, not per token. The result is multimodal AI, text, images, audio running on the phone, powered by a model that would traditionally need a GPU server. For robotics, this is directly relevant. The argument that robots need the cloud because effective models are too big to run locally just got a lot weaker. Apple is running a 20 billion parameter model on a phone with a battery. A robot with a Mac Studio or an NVIDIA Jetson has considerably more thermal and power budget. The hybrid architecture. Here's why the overall architecture matters for robotics. Robots in the field, on the lunar surface, in remote sites, underwater, in hospitals, face a problem the rest of the AI industry has almost ignored. How do you run capable AI without reliable cloud connection? For years, most AI systems assume connectivity. Send data to the server, get an answer back, and if the connection drops, the system breaks. That works fine on a phone in a city. It doesn't work for a robot making real-time decisions. Apple's answer, and it's the same the best robotic teams have been converging on, is a hybrid architecture. Run as much as possible on device, use the cloud for what local models can't handle. Route between them intelligently. Keep the data private at every step. Apple didn't invent this idea, but Apple shipped it to 1 billion devices with full weight of its hardware, software, and silicon teams behind it. Specifically, privacy is secondary to latency and reliability, at least for now. But Apple's private cloud compute architecture is still worth understanding. PCC has 5 rules. Data is processed and wiped, never stored. Even Apple operators can't access it. No backdoors, attackers can't target specific users, and the software is published so outside researchers can verify everything. The top model runs on NVIDIA GPUs in Google Cloud, but inside an enclave that Apple fully controls, your device only trusts software that's cryptographically signed by Apple. Even though the hardware is Google's, Google cannot see the data. For robots in hospitals, industry facilities, or government sites, this will eventually matter. Today, the priority is making local inference work at all, but the fact that Apple built privacy into the routing layer from the start rather than bolting it on later is worth noting. To be fair, this is real progress, but it's not the whole story. The on-device model is still smaller than cloud models. It activates 1 to 4 billion parameters per prompt. Cloud models are orders of magnitude larger for frontier reasoning. Apple's approach is good enough for most tasks, not replaces all cloud AI. It's gated by expensive hardware. The 20 billion model needs A19 Pro or M4 chips with 12 gigs of RAM. That's a top tier. Older devices get the 3 billion model only. Cloud fallback still exists and has limits. Siri AI has daily usage limits. Higher limits require iCloud Plus. This tells that cloud inference is still expensive and Apple is rationing it. It's English only at launch, not available in EU or China. Regulatory friction is real for Apple too. Any robots deployed globally will face the same issue. And Apple is catching up, not leading. Google has been doing on-device AI for years. Samsung, Qualcomm, others are here first. Apple is validating the approach, not pioneering it. Here's what I want you to take away from this. Step back and look at the direction of the whole industry. Apple ships a 20 billion on-device model in phones, watches, and laptops. Nvidia launches Cosmos 3 for robot world models and RTX Sparks for a petaflop of AI in laptops. Microsoft built its own AI model family and moves away from OpenAI. Amazon deploys warehouse robots with increasing autonomy. Every major player is converging on the same idea: intelligence that works without a constant cloud connection. The question is no longer should AI run locally, it's how do we make the local model capable enough? For robots that need to operate where the cloud cannot reach, Apple's answer: a sparse, multimodal 20 billion model on device, a private cloud fallback, and an orchestrator that routes between them, is the most production-ready version of this architecture the industry has shipped. The hardware is ready, the models are here, the privacy architecture exists, the developer tools are shipping now. That's a signal. And I think that's the most important thing to come out of WWDC this year, even if almost nobody is talking about it this way. If you found this useful, I'd love to hear what you think. Are you working on local AI for robotics or edge applications? What's your setup? Drop a comment and let me know. And if you want more content like this, where I break down what actually matters in AI and robotics without the hype, subscribe. I'll see you in the next one.